What is different in these? Because you'll notice all the way across, 1, 1, 1, 2, 2, 2, 0, 0, 0. What's different? Do they all have this number out front? Yep. Do they all have a denominator? Yep. So the only thing left is what's under the square root sign, right? What's different? It's 0 or positive or negative. So that should tell you something, yes? What does that tell you? Square root, here, the b squared minus 4ac has 3 options, doesn't it? It can be greater than 0, which would make it positive. Yes? It could be equal 0. Or it could be less than 0, which would make it negative. Now, how does this help us? Well, if it's positive, like in row 2, it means we're going to have 2 roots. The roots are x values. They're x-intercepts. If it's an x-intercept, how do we write it like an ordered pair? What would it look like? It would be x, 0. And how many of them would there be? 2. What if it's 0? There's only 1 root. But this is where it gets weird. It's still plus or minus, isn't it? So technically, even though there's only 1 visible root, what we really have are 2 equal roots. Does everybody understand what I'm saying? On a graph, there's only going to be 1 x, 0. So it looks like there's only 1 root, but because it's a quadratic equation, it's technically 2 roots. Everybody understand? And obviously the third one is negative. There will be no roots, which means there is no x zeros anywhere. Now I want to show you this with the graphing calculators, so doubly, because it allows us to practice the graphing calculators one more time, and it allows you to see what these graphs are going to look like. Everybody good? If you don't have a graphing calculator, come and get one. Leave a phone. Why are you guys so mean to Riley? He's a gentle soul.
Mr. Meyer, this one's
Is that the last one?
Yes.
Why don't you take mine? Yeah, just leave it there. Thanks. Okay, everybody. Do we all remember how to do this? We're only going to do 1A, 2A, and 3A. So, How do we put this into our calculators? We hit Y, and we get to this screen. Get it cleared off, and we're only going to enter 1A. So, where do we get the X button? What does it look like on your calculator? XT theta n. And we hit it, and it comes up as an X. Now, remember, if we're doing a physics equation, are we necessarily going to have X and Y? No, we might have distance and time, right? Or something like that. The X, the button that gives us X, gives us the independent variable, whatever it may be, right? And then it is squared, so we hit the squared button. There's my X squared. Now, this minus, I have to remember to use the subtraction button, not this negative button. Minus 8x plus 16. Everybody cool? And then we're going to hit graph. Now, some of your windows might be messed up and you might not see the graph, right? We'll deal with that if it happens. Graph. Was everybody able to make a parabola? Everybody? Battery's dead. Yeah. Is there any left? There you go. Here, let me have that dead battery one because I got to buy new batteries. Is everybody cool? Now, we already know, because we did the real math, that the x-intercept is what? 4, right? We already did that. So let's use our calculator to find it. Does everybody remember how? If you don't, follow along. I'm trying to calculate something, yes? So right there, it says calc. Second, calc. And there's all my choices. What am I seeking? Of all those things, what do I want? It's not, you want the 0. You want, right? So we're going to hit 2. And then we're back at this left boundary, right boundary thing. We know the 0 is right around there, yes? So I use my arrow keys like I'm playing on a Nintendo Entertainment System, the old school one. Yeah. No. No. I'm going before that. There is my cursor, yes? Is it to the left of the value that I seek? Yep. So I hit enter. Now I want the right boundary. So I'm going over on the right of the value I seek. Now what is really happening here? We are telling our calculator to look for any zeros that exist between my left boundary and my right boundary. And we can quite plainly see it looks like there is one, yes? Now we know that it is 4 because we actually did the math. Enter. Guess. I would like you to tell me it, yes. 3.99999999997. What is that really? 4. Everybody understand? Everybody cool? All right. You guys do the second one. Now, listen please. Listen please. Do not clear this. If you have already, it's not a problem. If you haven't yet, I would like you to use your arrow keys, go down to Y2, and start entering 2A. X squared plus 5x minus 14. And then graph. Now, if you were on a standard window, 10 by 10-ish. This should be the one you see, yeah? Notice we don't see the bottom of it. If we wanted to see the bottom of it, what would we have to do? Move our window. We'd have to pull it out. We'd have to make the Y's longer. Everybody cool? We don't care about that, though, because we only care about the zeros right now, yes? Now, let's remember that we already know this answer, don't we? Approximately. What's the root of 67 again? Approximately? 8. So 2a is approximately negative 5 plus 8, which is 3 over 2, and negative 5 minus 8, which is negative 13 over 2. Everybody cool? Approximately. Everyone agree? Okay, so let's check now. Now, when I do second calc, 0, now I have 2 lines there, don't I? Right? Please notice, right now, I am working with y1. I didn't want y1, did I? So I gotta get, because if I move my cursor now, my cursor's not moving, there we go. If I move my cursor now, you can see that I am on the wrong curve. Does everybody see that? Now, if you cleared, you're going to be on the right curve, right? How many people are dealing with only one parabola right now? How many people cleared? Okay, so it's cool. So, Sarah, just go ahead and work on the curve you have. For everybody else, we've got 2 curves here. So we got to get on to the other curve, right? Right? So how am I going to do that? I go back to here, and I highlight there, and that should put me on the right curve. Ah! It didn't. There we go. You push down to get on the curve on this version of the calculator. So now you can see I'm on the correct curve, yes? Everybody sees? Now, am I to the left of one of my zeros? Am I? So can I push enter? Okay. Now, I'm dealing with this 0 right here, so I got to get to the right of it. Am I to the right of it now? And I know that because I've switched to positive y's. Enter. Now, when I push guess, this is the larger of the 2 zeros, isn't it? Right? And we know that one of our zeros should be around 3 halves, 1.5, right? So when I push guess, I should get around 1.5. I got 2. Was it supposed to be 67? 25 plus 42. Did I write the wrong one? It could have. I was right in all 3. I made some errors. Let's check. 5, 14. 5 squared is 25. 4 times 14. Oh, it's not 42. I did 3 times 14. It should have been 25 and 56. Why you guys all let me write 67? Yeah. Why you not say anything? I did 3 times 42, not 4, or 3 times 14, not 4 times 14. What an idiot. Well, that's only worth half marks. How embarrassing. But does the principle still stand? We have to, I don't know. Mr. Como might be sitting at his desk. Nothing? Half a laugh? Okay. Principle still stands. So, 1A, what did the graph look like? It bounces off the x-axis. And it hits it just that one time. For number 2, what's it going to look like? It hits the x-axis twice. Right? Now let's graph the third one. This time, let's clear these. And that third one looked like x squared plus 3x plus 6. And you can see that it never hits the x-axis. So for number 3, it is a fake. Number 3 looks like this and never touches the x-axis. Everybody cool? Now, please notice that we did not need the graphing calculator at all, did we? We were able, if we could multiply 14 times 4, we could have done all this work without ever touching the calculator, yes? And I would like for you to please notice how much actually easier this is than dealing with the graphing calculator. At this point, right? Because you haven't practiced with the calculator yet. It's a pain. But this, it's add, subtract, multiply, and divide, which we've been doing for how long? Please say 12 years. Thank you. Everybody good? All right. So here's all that stuff that we just wrote about. This right here, that lives in the quadratic equation. And this, son of a... This is what we call the discriminant. Now, what word do you see in there? Discriminate. This part of the quadratic formula is called the discriminant because it tells us what the quadratic is going to look like. Because it has to be one of those three things. It has to be two different roots. That's the one that looks like this. Hits the x twice. Two equal real roots. Remember, that appears as one root. And it looks like this. It bounces off the x-axis. And then the third one is, of course, never touches the x-axis. Everybody cool? Now, only using the discriminant, tell me what this graph is going to look like. So, the discriminant is only this part. So what do I have to use in A? What's going in for B? 6 squared plus 4 times what? Minus. 4 times 9 times what? 1. What is 6 squared? 36 minus what's 4 times 9? 36, which means the discriminant equals what? 0. So what's the graph going to look like? 2 equal real roots, which means it's going to bounce off the x-axis, right? Something like that. Everybody good? Now, what's weird about B? There's a fraction. What else is weird about it? It's on the other side, Emma. It doesn't equal 0. And there's one other thing about that makes it weird for this unit. What's missing? The x is not squared. Okay? Now, if we're going to do this, I need, that was A, this is B. If we're going to do this, I need that type of quadratic, don't I? But we've done grade 8, 9, and 10 algebra, right? So can we make that look like that? How? Move everything to one side. Good start. And then what bothers us? So let's move everything to one side. I'm going to leave this x here because it's positive. Emma? There you go. So I'm going to move everything to one side. And since Emma has given us away on the next step, I'm going to leave the 3x there. Because when we square it, if we'd done what I was going to do, it was going to end up negative, then we would have to move it again. But because you're half a step ahead of me, we can leave it there, right? So I've got 3x minus 4 over x minus 5. And what does that all equal now? 0. Now we're getting close, right? Now, as Emma says, we got to get rid of this x, because do you see any fractions here? No. So we're going to multiply everything by x, giving us 3x squared minus what? 4 minus 5x equals 0. Now, is this okay? It's okay, but it's not okay, right? What if we're thinking this is fine, but if we're just must follow the formula, does this work? No, because in this one, what's C? 4. But it would appear that it's 5x, right? So the smart thing to do here would be to put it into this form. 3x squared minus 5x minus 4 equals 0. Now can I do the discriminant? And the discriminant is b squared minus 4ac, which is 25 minus 4. What's a? What's a? 3. What's c? Negative 4. 25. What's negative 4 times 3? Negative 12. What's negative 12 times negative 4? Positive 48. So it's 25 plus 48, which is 68, 73. Is that bigger than 0? So how many roots am I going to have? 2, which means what will the graph look like? It'll hit the x-axis twice. Everybody cool? Why do we use this? Hopefully you're starting to see that quadratics is going to get a little complicated, right? You can check very quickly, just by doing this, what your graph is going to look like. Then, if you do a graph and it doesn't look like that, you know you've made a mistake, and you wouldn't bother to hand it in. Does everybody understand? All right. So, read that question. Find the values of p so x will have no real roots. So, what shows me the roots? That's awesome! I know what it is. It's the Macarena.
I can't find it.
When my kids got their first Wii, they made me's of everybody in the family. I listened to that so long because it's a big family. So we only care about the discriminant, right? And if it's got no roots, the discriminant must be what? Negative. So b squared minus 4ac must be less than 0, correct? Everyone agrees? Okay. What is b squared minus 4ac in this quadratic? What's b? P. So p squared minus 4 times what? What's a? 1. And what's 25? Less than 0. So p squared minus 100 must be less than 0. We know how to solve that. P squared must be less than what? Positive 100. So p squared must be less than what? 10. If p is less than 10, no roots. Everybody understand? You guys do that for this one now. 2 different real roots. Must be what? Greater than 0. Go. Hey, Riley, I'll have that cumulative marked and back to you tomorrow, okay? And Emma, you too. Tomorrow, I'll have them done. Now, here we're in trouble, aren't we? Right? Why are we in trouble here? Well, 24 doesn't have a square root. We know that, right? But we're also intelligent enough to know that the square root of 24 is also 2 root 6, right? And it also is a decimal. Yeah? Because we know that quadratics are going to have uses in real life, and in real life we need to find that square root, right? But the problem isn't that. If it's got two different roots, it's going to look like this, isn't it? Right? Now, it's possible it'll look like this. If it looks like this, what do I know about those two roots? They're both positives, right? If it looks like this, what do I know about those two roots? They're both negative. If it looks like this, what's it going to be? One positive, one negative. Agreed? How is that happening? It's happening because we're forgetting, and we didn't do it the last time, because as soon as we saw p squared equals 100, what did we all say? Every single one of you said the answer to me out loud. What'd you say? 10. Why? Because what's the square root of 100? What did you forget? Somebody said it over there. What'd you forget? They're positive or negative, aren't they? So this is really positive or negative root 24, isn't it? And what is this one really? Positive or negative 10. Right? So, in this one, there's 0, there's positive 10, there's negative 10. All of these values. Everybody cool? What makes this one different? What's the root of 24 approximately? It's a little less than 5, right? Because root 25 is 5. So if it's either positive 5, there's 0, there's 5. It can be any values bigger than 5, right? Right? But it also can be less than negative root 24. Because I got to go this way. Now, how do you check this? What's the easiest number to work with of those three numbers I've written there? I've written negative 5, 0, and 5. What's the easiest one to work with? 0. If I put 0 for k, right, I get 2x squared plus 3. Yeah? 2x squared equals negative 3. X squared equals negative 3 halves. Yes? Can I square root negative 3 halves? Can I? No. So is 0 a number that works? So that's how I know that once I have my roots, everything in there doesn't work, because 0 doesn't work. So it has to be bigger than 5 or less than negative 5. Everyone cool? Everybody with me? Now, what happened back up here? What's the easiest number to work with there? 0, agreed? I know it's going to be plus or minus 10, right? Check with 0. That's going to be x squared plus 25, right? Equals 0, so x squared equals negative 25. Can I do that? Can I? So is 0 going to be allowed? No, so where must my values be? Right there and right there. Can't be in the middle. Everybody with me? Okay. You guys do the rest of 90 and 91, and that's it. Remember, we're only looking at the discriminant. Now, we got to do that quiz. Quizzes don't count. Can we do it tomorrow? All right. We're going to do our first quiz tomorrow, but for your own purposes, it only goes up to and includes up to 4.3. Up to and including this page, 83. And no graphing calculator. I am 99% sure I will never be testing you on using the graphing calculator. But it's available to you if you wish. Do you understand what I'm saying? Okay? Every question I give you is doable with math. Everybody good? Go.